Tough question 11.2, the final question on the paper. Amine F can be prepared by a three-step synthesis. That means there's 3 steps in making or turning methylbenzene, starting from methylbenzene into amine F. So we've got to get methylbenzene, which is a benzene ring with the CH3 on it, into amine F, and there's going to be 3 steps. We need to work out what the steps are, give reagents and conditions. We don't need equations and mechanisms, but structures of what's going on. So let's have a look at amine F and let's have a look at methylbenzene. So let's go back and have a look at amine F. Amine F is a benzene ring, but it's got a CH2, CH2, NH2. A methyl group's only got a CH3. I've added not just the NH2, but I've added an extra carbon. The only way I can add an extra carbon is by adding a cyanide, using cyanide, potassium cyanide. So I need potassium cyanide to add onto this chain. Now, a methyl group won't allow potassium cyanide, a cyanide ion, to add on. So the methyl group needs to turn into something like have a Cl on it or a Br on it, so that the Cl minus can replace with nucleophilic substitution that Br. So let's have a look then. So methylbenzene, I need to put a Cl onto the CH3. We can do that by using chlorine and UV light. We've seen something similar during a free radical reaction. So use chlorine and UV light to replace one of the H's with a Cl. And then what we can do is we can add potassium cyanide. You need alcohol and water. Potassium cyanide needs alcohol and water as a solvent in there. So the cyanide then replaces the Cl by nucleophilic substitution. And now I've lengthened that chain. So the key was to lengthen the chain to 2 carbons long off the benzene from a methyl group. That was the clue, that we needed potassium cyanide in alcohol and water. And now we've got potassium cyanide, all I need to do is add H's on there to make CH2, CH2, that should say CH2, NH2. So a benzene ring with CH2, NH2 on there. And the easiest way to add H's is by using hydrogen and nickel.